enjoy demo days. That's what we call it. You got to see the different demos. I like Tinkerbell and Death of Tinkerbell and Exploding Milk Jug and that. We'll have different kinds during out the year, but they're a little bit different. Okay, so we are on to types of reactions. I went over a quick overview before we went back, so I'm going to go through them in your notes and sort of go back over them so you can write stuff down that you need to. I have left the posters up on the board, so if you want to use them, you can. And maybe they'll be helpful or not helpful, whatever. So the first one that we're going to talk about is single displacement. That's a light pink one up here. And I am all about stick figures because I am not an artist. So if you need to draw stick figures, that's fine for me. Remember that single displacement, it could be the negative side that's getting switched, which was represented here by the girls, or it could be the positive side that gets switched by what's represented here by the guys. This was the silver tree. When we made the silver tree, that was a single displacement, where copper got kicked out and silver went into the compound. Okay? So write what you need to remember what that is. And again, there's more up on the board. It's the light pink. These posters will be up here for a minute, yeah. So compound and element, new compound, new element. Compound and element, new compound, new element. So depending on if the girl or the guy is switched. So it was not anything other than you write something like that down. However you need to describe single displacement. And it is up there on the light pink poster in the up front. Double displacement is when two compounds switch partners. Okay, how many have reached in math where you learn about FOIL? How many have learned about FOIL in math? Okay, first, outside, inside, last, right? Well, in chemistry, we don't use FOIL, we use OI. Okay, outside, inside. So if you'll notice here, my outsides went together, and my insides went together as I changed sides. So they switch partners. The positive, or the guy, is always on the left. Okay, so the positive ion is always written first. You still have to balance each individual thing. So I'm like making a new compound. So I don't take subscripts over unless it's part of a polyatomic. Okay, so if it said BaCl2 and I was mixing it with silver, then I would make silver chloride on the other side, but I only need one chlorine to go with one silver. So I wouldn't take that subscript 2 over. And we'll be doing more of that later so you can know what they are. But compound, compound, new compound, new compound. So double displacement. Okay? Another way to look at it, remember outsides, the yellow and the white went together, and the green and the red went together on the other side. Okay? Acid base is a specialized double displacement. It's a double displacement that makes water. Okay? And the reason it makes water, if you look at the outsides here, H and OH actually make water. HOH is water. And the inside is NaNCl. That's a salt. So a specialized type is acid base. We'll get more into acid base after Christmas. More into third term. And we know acids. We haven't talked about bases, but the stronger bases have an OH at the ending. That's why they easily make water. Okay, combination or synthesis. When we take something as an element and make a compound. But we can also take, like the Brady Bunch, a mom and kids and a dad and kids and put them together and make a family. That is a synthesis. If you go onto YouTube, you can actually watch this synthesis where he takes sodium metal and chlorine gas and sparks it so it makes salt, and he salts his popcorn that he's just made. Now, I don't know if I'm brave enough to eat popcorn after doing that because you have to have the ratios just right so you don't have any extra chlorine gas or any extra sodium, because putting sodium in your mouth would be really bad for your health because sodium metal will turn to sodium hydroxide and burn your mouth. Okay, so this was our boy meets girl, okay, and we have a couple. But we know couples always decompose, it seems like, especially in high school. After high school, we can hang around for a little bit longer. But remember, it doesn't have to just be to elements. It could be a compound moving to 2 or more compounds. So this is 1. So just remember, decomposition falls apart. It was 1, and now it's 2 or more things. It doesn't have to go to elements. So 1 thing, 2 or more things. So these right here are also decomposition reactions. Probably things, these are ones that go to from a compound to 2 compounds. So the other one I just went from was just a compound to 2 elements. So it's just, decomposition is just 1 thing falling apart to 2 or more. It doesn't matter if it's elements or compounds. Here we've got lime, which is calcium carbonate, and it goes down to calcium oxide and carbon dioxide. Right here is what you see in pop. This is carbonic acid. Carbonic acid, when you open up a pop, the carbon dioxide starts to come out, starts to bubble. As it bubbles away, it leaves water. So if we leave that pop open too long, we end up with what we call flat pop, right? And it doesn't taste really good. The reason why is the flavoring has now been diluted by the carbonic acid turning into water and carbon dioxide. Okay, so this is a fairly slow process unless you have a catalyst like we did with the elephant toothpaste. We put potassium iodide in there. Well, have you ever done Mentos and Diet Coke? That Mentos is that catalyst. It just speeds up this reaction so it goes really fast. Okay? So that's what a catalyst does. It sort of speeds things up. This right here is sulfuric acid will break down into water and sulfur dioxide. This is where we have problems with air quality. Ammonium hydroxide breaking down into water and ammonia. This is if your mom uses ammonia at home and you know that smell. That's ammonia gas. What's left behind is the water. The cleaning thing is the ammonium hydroxide. So if you leave ammonium open too long, what's going to be left in the bottle? Just water. Because the ammonia gas will come out of it. So when you use ammonia at home, you need to use it quickly, relative. Again, think pop. Okay. Relative, you need to use it fairly quickly. Make sure you put the cap back on. Okay, and then your favorite, combustion. Combustion. We get a reaction of fuel with oxygen producing lots of energy. We saw energy and heat and light and sound while we were in lab. A lot of the ones that we did were with methane. This was the methane bubbles. This was the whoosh bottle. Well, actually, the whoosh bottle was methanol. It has an extra O in there. But you have to add so many oxygens to it to get carbon dioxide and water. Combustion is a big problem for firefighters and EMS and hospitals. And about this time of year, they're telling everybody, please have your furnace checked. Please make sure your carbon monoxide monitors work. Because in the summertime, we have spiders, we have bugs, we have all kinds of critters that get into the hole that supplies the oxygen to our furnace. And if that's not clean, if there's a spider web, if there's something in there that's stopping the air flow from getting into the furnace, then we end up with incomplete combustion. And when we end up with incomplete combustion, yeah, we've had some fire that we combust and we're trying to make heat, but we also make carbon monoxide. And carbon monoxide becomes a big problem. And the big problem is people think they've got the flu. These are the symptoms of carbon monoxide poisoning. Headaches, that's how it starts. Nausea, start throwing up. Dizziness, well, if you've thrown up enough and you've ever been sick with the flu enough, you know after you throw up you get a little lightheaded. So you still think it was the flu, right? The next step, though, in the progression is you get breathlessness. You can't quite get a full breath. At that point, you better get outside and get some fresh air, call 911, get them over there. Because if you collapse, the chances of you being found before you die are minimal. Okay? If they get to you where you're at the breathless state or you've just collapsed, they can possibly get you to a hospital fast enough to put you in what's called a hyperbaric chamber. And my sister had to be in one of those because they do wound care in there too. They force oxygen into you. So they pressurize the oxygen and it comes into you. But it's sort of like the best way to describe it is like a coffin with a glass area on top. And they seal you in there and they pressurize it and they force the oxygen in. The reason why carbon monoxide is so bad is in your hemoglobin that carries your oxygen to the different parts of your body and then releases it at different parts of your body. Well, carbon monoxide bonds the same place that oxygen would, but it doesn't release. It stays on there. And so as you breathe in more carbon monoxide, it takes more of your hemoglobin to the point where not very much oxygen is being transported by this hemoglobin because they're all gummed up with the carbon monoxide. And so they have to force that off with high pressure hyperbaric chambers. So that's what that's about. You've also probably heard when divers dive down, they have to come up slowly. And that's because of the gas in their blood. If they come up too fast, the gas in the blood actually can basically implode them from inside. Or the bends. Yeah. If they come up and the bends are not too bad and they get them in a pressure hyperbaric chamber fast, then they're okay. The bigger hyperbaric chambers are down like at the U of U. I think LDS Hospital has one. Those are ones that you can actually walk into and you can walk around while they're doing the pressurized. But the ones at Lakeview, the one down, the hospital down in Bountiful, I can't think of his name, McKay-Dee and Ogden Regional just have the hyperbaric chamber where it's like a coffin you're in. So if you're claustrophobic, it's crazy. Okay, so that takes us through all the types of reactions. So I want to go over a couple of them with you in your practice right now. So let's look at the first one. What's the first thing in the first one? Compound or element? Compound. What's the second thing in the first one? Compound. Then we have the arrow. What's the next thing? Compound. What's the last thing? Compound. So what type of reaction am I going to get? Compound, compound, new compound, new compound. Double displacement. Or what I like to call, to help me remember, dance disaster. Remember we had the dance up here, the two guys, and the girls got mad at them and we switched them places. That's dance disaster. That helps me remember double displacement. Okay? All right, let's look at the next one. Element or compound for the first thing? Element. Next thing? Element. Then an arrow, right? Then what do we get on the other side of the arrow? Compound. So what is it? Synthesis, because I'm putting things together into one thing. Good. Okay, let's look at the next thing. Number 3, we start with a compound plus element. What's the element? Oxygen. Okay, that might be a clue. Yields what? A compound. What's that compound? Carbon dioxide. Okay, plus another compound which is water. Okay, there's 3 things there that clue you off. It's a special type of reaction. The oxygen on the reactants and the carbon dioxide and water in the products. Which type is it? Combustion. Okay, good. That was number 3. Okay, let's look at number 4. What do I start with? Element. What do I have next? Compound. And so I'm really looking for that element oxygen. If it's not there, I don't worry about it. Okay, so element, compound. Then I have an arrow, right? What do I get now? A new compound and a new element. What am I doing? Single displacement. Good. Okay, so now I'm going to skip to the next page because I want you to have enough time to do that. But we were having problems with some of the remembering of this last at the bottom. Okay, so this last part at the bottom, where you have to write the isotopic symbol. And you have to figure out protons, neutrons, electrons, blah, blah. I think I need to pound this in your head. This is something we need till the end of the year. Okay, so don't forget it. We just have to keep going back over it. The first one, actually I don't want to do the first one. I want to do number, which one is it? Oh, never mind. I guess I'll do the first one. Potassium 37. And they say write the isotopic symbol. Isotopic symbol, oh, I've got to have the symbol. What is the symbol for potassium? K. So I'm going to write a K. But in that symbol, I have to have the mass number on the top. What's on the bottom? The atomic number. So what is the mass number? Yeah, right there, 37. So right where it says mass number, I can also put 37. Okay, so what's the atomic number? 19. So the atomic number is 19, and that number goes right here. So that's my atomic number, so I can put it in two places. Okay, this right here is my isotopic symbol. Since they did not give me a charge, which they didn't, I don't put a charge with the isotopic symbol. If they gave me a charge, I put a charge with it. Okay? Now, what else is the atomic number? What does it tell me? Number of protons. If there's no charge, then the protons equal the electrons, right? How do I find the neutrons?
So you write the 37K19 in the isotope symbol?
Yep.
You do the atomic number minus mass number.
Other way. Mass number minus atomic number, and that's going to give me, I'm not going to do it. You guys got to do it. That's neutrons. Okay, what happens if I have a charge, though? My protons never change. Only my electrons can change. So if I end up with a negative number, do I have more electrons than protons or more protons than electrons? More electrons. So if I end up with a negative number, I'm actually going to add that number to the number of protons I have, so I have more electrons. Okay, and if I end up with a positive number, that means I have more protons than neutrons, so I'm going to subtract from that number to get to it. Okay, so that's just a real quick reminder of how to do that. It's just the page we were on and this page. That's the daily work for today, and put it up, and I'll come around and get your quiz scores. Okay, any questions? Yes?
So if it says like -2, then
So-
what's the number of electrons too?
2 less than the number of electrons it has, or 2 more, sorry, 2 more.
Okay.
So it would be 8 plus 2, so that would be 10.
Oh, okay. So the sign goes opposite.
Yeah. Okay, I'll be